Now, there are two main types of weather satellites, the first of which is called polar orbiting. As its name suggests, a polar orbiting satellite orbits latitudinally over the poles. They're situated about 500 miles or so above Earth's surface, and they orbit the Earth about 14 times per day. Polar orbiting satellites are very good at giving us highly detailed imagery of the poles, but not so much the rest of the globe. This is where the second type of weather satellite comes in, which are called geostationary satellites. Geo meaning Earth, stationary meaning not moving. So, geostationary satellites hover continuously over a single fixed location on Earth's surface. Essentially, they're synced to Earth's rotation, so they orbit just once around the Earth per day. This provides us with a lot of advantages. Geostationary satellites can give us continuous coverage of certain regions at all times of the day due to the geostationary nature of the satellite itself. They can record images much more frequently than polar orbiting satellites. Geostationary satellites can give us new images up to every minute. And because they're focused on a fixed location on Earth's surface, we can analyze the actual motion of the clouds below, which of course is highly critical to severe weather forecasting and nowcasting.
The Chaser Academy is our premium subscription, and it's the best deal in storm chasing. Link in the description.
Now, geostationary satellites orbit at an altitude of about 22,000 miles above Earth's surface, so they're not quite as high resolution as polar orbiting satellites, but with the advances that have been made in the past few decades with geostationary satellites, we can still get very high resolution data of a much larger chunk of the globe than polar orbiting satellites can give us. And the numerous advantages that geostationary satellites give us really outweigh those of polar orbiting satellites. The main satellites we use for weather forecasting here in the US are the GOES satellites. GOES stands for Geostationary Operational Environmental Satellites. Chances are, any of your favorite weather data sites that offer satellite data, they are going to show you data from the GOES satellites. There have been several iterations of the GOES satellites since GOES 1 was launched in 1975. Today we're up to GOES 18 and GOES 19. The GOES suite is occupied by two main global sectors, GOES East and GOES West. Essentially, these are the two main fixed locations above which the satellites are hovering. The GOES East position is currently occupied by the GOES 19 satellite, while the GOES West position is currently occupied by the GOES 18 satellite. Zooming in on our full GOES West sector, you can see how expansive it is. The GOES West and GOES East sectors make up over half the globe, so we have quite the vast expanse that we can analyze using satellite imagery from the GOES satellites. Note that the resolution is somewhat degraded near the poles, but elsewhere the resolution is quite high. And because the resolution is so high, we can zoom into even smaller sectors that give us a really honed-in look at much smaller regions, which of course is quite useful for severe weather analysis. Typically in these smaller sectors, new imagery will come in every 5 minutes, but on big severe weather days or for tropical cyclones, we can use the mesoscale floater sectors. These mesoscale floater sectors move around. So based on where the best chances for severe weather are or where the tropical cyclone is located, these sectors move around. Now, what's nice about these mesoscale floater sectors is that the new imagery comes in every minute, which gives us an even higher temporal resolution look at the data and can allow us to see really intricate changes in these systems over a short period of time.
Remember to check out those links in the description below, and then watch another video.